Okay, so today we're talking about the factor theorem, and this is a very important theorem because it helps us to factorize polynomials. So it states that if f of x is a polynomial and we have that f of p equals 0, so p is a root, kind of think of a polynomial, it goes through the x-axis at p, then it tells us that x minus p, this linear term, is a factor of f of x. So this actually divides perfectly into this polynomial. So we're going to look at a couple examples just to make sense of this. So for example, if we have this polynomial, this cubic, which is x cubed minus 2x squared minus 13x minus 10, and we have this question which is show that x plus 1 is a factor. So we can do this two ways. We can use this theorem, which is going to be really quick, or we can do it using polynomial division, which we're looking at the previous video. So we're going to compare both methods. So let's use this theorem. We want to show this is a factor. So what we can do is we can evaluate at the point, we need to decide which point it is and see if it equals 0. So comparing x plus 1 with x minus p, we need to evaluate at the point minus 1. So if we can show that f of minus 1 equals 0, then from this theorem it tells us that this is a factor. So let's just plug in minus 1, and so we have minus 1 cubed minus 2 times minus 1 squared, minus 13 times minus 1 minus 10. And you can use a calculator, or you can just simplify by hand. Let's do it by hand. We have minus 1, and this is minus 2. This is plus 13 minus 10. And then you see that this is actually minus 13 plus 13, so it is indeed 0. So just from this theorem, we can immediately find out that x plus 1 is a factor, is a whole factor of this cubic. So one downside to that, although it's very quick, it doesn't actually tell us what the other factors are. But now we know this is a factor, we can use polynomial division to find what would be left over. Although it's a bit longer, it tells us what the remainder is, like what's left over when we factorize this. So let's do this just on this side. So if I write out the polynomial again, x cubed minus 2x squared minus 13x minus 10, and we draw the division symbol, and then we want to divide by this term, so we want to divide by x plus 1. And we know that the remainder is going to be 0 from this theorem. We just need to work out what's left over. So let's use our method. We take the leading term, which is x, and we divide it by x cubed, and this gives us x squared. And then the second step is to multiply this answer by the thing we're dividing by. So this gives us x cubed plus x squared. And then the third step is just to subtract by this. So I'm going to draw brackets here and a minus sign. And we want to subtract this line by the first line. And you can see now why we did this, because the highest term is going to cancel out, the x cubes cancel out. And then we're just left with minus 3x squared minus 13x minus 10. And then we just iterate this process to get rid of all the terms here. So again, we just divide by x. And I won't go through all the details very carefully, I'll just do it quickly. So yeah, so if we divide this by x, we have minus 3x, then multiply this down, we have minus 3x squared minus 3x. Draw brackets here, subtract this term off, this cancels, we have this double minus turned into plus, we have minus 10x minus 10. And one more time, just get rid of the linear term, divide by x, we get minus 10. Then multiply this down, we have minus 10x minus 10, subtract this off, and we get a remainder of 0, which is exactly what we expected. But because we did this, we see that when we divide this cubic by this linear factor, our remainder, well, the other thing that factorizes is this quadratic. So let me just write it out at the bottom. It tells us that the cubic x cubed minus 2x squared minus 13x minus 10, this equals x plus 1, and then the other factor that we multiply is this answer, so it's x squared minus 3x minus 10. And we can also kind of see why this theorem is kind of true. So if I write f of x here, which is what this function is, and now if you think about evaluating this function at minus 1, which is what we did up here, we showed doing all the steps, we showed it was equal to 0. But now if you think about subbing minus 1 into this factorized form, If we put minus 1 into this bracket, this is just 0. So whatever this stuff equals, doesn't matter if it's 0 or non-zero, when we multiply by 0, it's going to give us an answer of 0. So you can kind of see why this has to be a factor, because otherwise we wouldn't get the 0. So that's kind of another way to understand this theorem. So let's just look at one more example to make sure we understand it all. I'm just going to wipe off the board and then we'll have a look. Okay, so for this example, we're going to use the factor theorem to factorize this cubic. And the way we do that is we can test some values to find where f of x equals 0, and it would give us one of the factors. And then we can use polynomial division to find the other factor, which would be a quadratic, and we can factorize quadratics quite easily. So if you test a few values, it's good to start off with some simple numbers. So you can try 0, and we'd see that f of 0 is minus 12. So x minus 0 is not a factor. We could also try minus 1, like before. And if you do that, it comes out to minus 12. So again, it's not a factor. But then maybe if you try f of 1, then if you do this, you see that 1 to the power of anything is just 1. So we'd have 1 plus 6 plus 5, which is 12. And then we have the minus 12. So we see, just from a few examples, we found one of the factors already. We found that x minus 1 is a factor of this polynomial. So it doesn't tell us the other factors, but we can find that using polynomial division. So let's do that. I can write out the polynomial again. We have x cubed plus 6x squared plus 5x minus 12. And we want to divide this by one of the factors we find out. So we know that f of 1 equals 0. And if you think about this theorem with p equals 1, it tells us that x minus 1 is one of the factors. And to find the other factors, we need to do division. So divide x cubed by x, this gives us x squared. Then multiply this down to balance the books. We get x cubed minus x squared here. And we need to subtract this term off from the first line. And then the x cubes cancel. We have double minus here, which turns into 7x squared plus 5x minus 12. And then we repeat. So we divide the leading term by x again. We get plus 7x. Multiply this down. We have 7x squared minus 7x. And then subtract this term off. 7x squareds cancel. And then what we're left with, so the double minus here turns into a plus. We have plus 12x minus 12. One more time to get rid of the x's, we divide this by x, and this gives us plus 12. If we multiply x minus 1 by 12, this actually gives us this. We subtract this off and we have a remainder of 0, which is actually what we expect, because we know already that this is a factor of this polynomial by the factor theorem. But what's really good for us is that it's told us what the other factor is. So from this division, we now know we can write f of x, which is this cubic, plus 5x minus 12. We can factorize this as x minus 1, and we've got a quadratic here, so x squared plus 7x plus 12. And we can actually factorize this quadratic again, so we're going to factorize it in terms of linear factors. And you see, thinking of 12 and 7, we need two numbers that multiply to give us 12 and add up to give us 7. And it turns out that the numbers we need are x plus 3 and x plus 4. And that's it, that's the answer to our question. So we've managed to factorize this cubic by using the factor theorem and polynomial division, and then we just factorize a quadratic.